So good morning again, dear students. So now we're having the next practical lesson number 15, uh, linear homogeneous and inhomogeneous higher order differential equations with constant coefficients. So mainly, we will mainly solve in homogeneous equation. But by the way, what does mean uh, a linear equation with constant coefficients? So all coefficients for all uh, derivatives are constant. So here, for example, 1 before the second derivative, minus 6 before the first derivative, and 9 before y.
Sorry, you're not sharing your screen.
Thank you for reminding. Yeah, forgot about it. And there is a message in the chat, maybe. Yeah, the second attendance, just a moment. By the way, the second attendance will be available after 9:30. But of course, I will create it for you. So don't worry. And so from 9:30 to 11:05. So it will be available in a few minutes. Yeah, and screen sharing. Okay, so yeah, so we have constant coefficients before y and its derivatives. So actually, yeah, so in all these cases, we have inhomogeneous linear equations, but yeah, why inhomogeneous? Because we have x in right part, so dependency on x. But actually, inhomogeneous equation, so how it is solved usually, we solve first of all correspondent homogeneous equation, and after that inhomogeneous. How to solve it? Let me first of all write down the equation. So 2x squared minus x plus 3. And now we will solve the corresponding homogeneous equation. How to solve it? First of all, we will write down a characteristic equation. How to write? How to from this characteristic equation, we so it will be equation that depends on variable k, and power of k will correspond to the order of the derivative. So in our case, k squared minus 6k plus 9 equals 0. And if we solve this equation, we will see that roots will be equal 3. So we have we have uh, uh, two roots, two same roots. So one root with multiplicity 2. And then how we will write? Yeah, so as we have here, so the answers that we have here are real numbers, so non-zero solutions. So it will be written as in the following form. So y0, it will be marked as solution of homogeneous equation. So y with index 0 equals c1 e in power of 3x. So these roots will be multiplied by e. And plus, because we have multiplicity of 2, so we will multiply the second, so this exponent will be multiplied by x. So this is the solution of the homogeneous equation. And how to solve the inhomogeneous equation? Actually, we can see that here we have the right part has the special form, and it is a polynomial. Polynomial of power of 2, and also we see that the control number of this polynomial equals 0, and it is not a root of the characteristic equation. So we will find a y partial as a partial solution will be found as a polynomial of power of 2 with undefined coefficients. And how to find it? We will substitute it into the initial equation. So this solution, partial solution, will be substituted to initial equation. And first of all, let us differentiate it. So y prime partial equals 2ax plus b. And y partial prime twice equals 2a. So now we will substitute it into the initial equation. So 2a minus 6 multiplied by 2ax plus b plus 9 ax squared plus bx plus c equals 2x squared minus x plus 3. So now we will find these undefined coefficients. So let's expand brackets, regroup coefficients. So 2a minus 12ax plus 6b plus 9ax squared plus bx plus 9bx plus 9c equals this expression. So now let's regroup. So 9ax and 9ax squared plus what about x in power of 1? So minus 12a plus 9b, and that's it about x. And what about power of 0? So 2a plus 6b and plus 9c. And it equals this expression. So we have the following system. So 9a equals 2. Minus 12a plus 9b equals minus 1. And 2a plus 6b plus 9c equals 3. We won't solve this system now, so we will just believe these answers. And we would, yeah, so we received the same system, so I will just write down the answers for this solution of the system. So a equals 2 over 9, b equals 5 over 27, and c equals 11 over 27. So the partial solution will be the following. So 2 over 9x square plus 5 over 27 x plus 11 over 27. And how the general solution will be found? It will be found as the sum of solution of homogeneous equation and their partial solution. So the general solution is the following. So C1 e in power of 3x plus C2x in power plus C2x e in power of 3x and plus this polynomial. So this is the generic solution, general solution. Any questions about this exercise? Okay, as I see, no questions. So now let's move to the to 1b. So we will have more practice with linear equations with constant coefficients. So y prime twice plus y equals e in power of x. So writing down the characteristic equation. So k k square plus y plus 1 equals 0. And here we can find that k equals plus minus I. So then it means that yeah, so we have complex numbers, so plus minus I. So the the solution of the homogeneous equation will be written down as cosine of x plus sine of x. So actually, this I is yeah. So it is. So it means the coefficient of argument of cosine and sine. Yeah, actually, we could write it down like C1 e in power of I plus C2 in plus C2 e in power of minus I, but it will be yeah, forgot of course the constants, but it will be transformed to the following form. So to trigonometric form, such complex number. So found such solution of the differential equation. Then, so this is part solution of the of the homogeneous equation. And what about partial solution? We can see that right part is the exponent, and control number of the exponent equals of this part equals 1. And it is not the root of this characteristic equation. So we just so we find the general solution, so the partial solution in the following form. The following form, so y partial will be equal a e in power of x. So so exponent multiplied by polynomial with power of a power of 0. Of course, y with the wave prime equals y, so y partial prime twice, and it will be equal a e in power of x. So let us substitute it into the initial equations. So we have so a e in power of x plus a e in power of x equals e in power of x. So 2a e in power of x equals e in power of x. And here we can find that a equals 1 over 2 easily. So y partial will be equal 1 over 2e in power of x. So the solution will be the following. So the general solution, so y 0 plus y partial, and it will be equal c1 cosine x plus c2 sine of x and plus 1 over 2 e in power of x. So that's it. Any questions about this exercise? Yeah, and the solution the same. Okay, if no questions, let's move to 1c. So the next equation, y prime twice minus 3y uh, uh, minus 3y prime plus 2y equals e in power of x multiplied by 3 minus 4x. Again, solving homogeneous equation, so writing down characteristic equation, so k2 minus 3 k square minus 3k plus 2 equals 0. So with using Viet theorem, we can see that roots are the following. So k1 equals 1 and k2 equals 2. So the solution, so the solution of the homogeneous equation will be the following: c1 e in power of so e in power of x plus c2 e in power of 2x. So they corresponds roots of the characteristic equation, and all roots are simple, so multiplicity both of them equals 1. Then the right part is the following. So it equals e in power of x multiplied by the polynomial, and the control number of this right part, so it is the power of exponent, so it equals 1. Equals 1, so and it is the root of the characteristic equation. So the partial solution will be found in the following form: x multiplied by e in power of x and multiplied by this polynomial with undefined coefficients. So yeah, let us rewrite it a little bit. So e in power of x, I will move x into brackets. So ax square plus bx. And now let's differentiate this partial solution to substitute it into the initial equation. So y prime equals so e in power of x. So remember that it is the product of functions. So e in power of x plus so we differentiated e in power of x first of all, and now differentiating the polynomial. So it will be plus 2a plus plus 2ax plus b. Then y prime twice will be equal. So again, differentiating this expression, so e in power of x. So first of all, we will differentiate e, and then differentiating this polynomial. So we have 2ax plus b plus 2a. And now let's simplify it a little bit. So ax squared plus bx plus 4ax here, and plus 2b plus 2a. So now we can substitute it into the initial equation. So substituting the second derivative minus e in power of minus 3e in power of x for the of the first derivative, and plus 2 e in power of x, so plus 2 y with wave, and it equals e in power of 3 minus 4x. So first of all, we will cancel e. We don't really need it. So we can cancel it because we know that exponent is always positive. It cannot be equal to 0, so we can divide by it. And now let's regroup all these coefficients. Yeah, first of all, we will expand brackets. So minus 3ax minus 3bx minus 6ax minus 3b plus 2ax squared plus 2bx. Then what will be simplified? So I can see that a square, so x square, so coefficients before x square will be cancelled. So 1 plus 2 minus 3. So simplifying it, then what about a? So what about x in power of 1? So 4ax minus 6x, so minus 2ax. Then what about bx? So here bx, so 1 minus 3 plus 2, so b will be eliminated. Yeah, by the way, let us eliminate b here. And what we actually have? So minus 2ax plus 2a minus b equals the following expression. So now we can find coefficients. So writing down the system. So minus 2a equals 3, minus equals minus 4, sorry. And 2a minus b equals 3. So a equals 2, and then b equals 1. Let us recheck here. Yeah, correct. So y partial will be equal e in power of x multiplied by 2ax square plus bx. Yeah, don't forget that it's multiplied also, so the polynomial multiplied by x. So the general solution will be the following. So again, y prime, so y0 plus y partial. So it will be the sum of these solutions. So yeah. So it will be written like this, and plus this. Yeah, we find coefficients. So this is the general solution of the initial equations. Any questions about this exercise? Okay, I guess that no questions. And let's check. Yeah, let's solve one more exercise, 1D. So another part of the another kind of right part. So minus 7 y prime plus 6y equals the sine of x. So first of all, writing down characteristic equation. So k square minus 7k plus 6 equals 0. So what do we have? K 1 equals 1 and k 2 equals 6. So found roots. So the solution of the homogeneous equation will be C1 e in power of x plus C2 e in power of 6x. And then what about the right part? The control number of the right part equals plus minus I, because we have sine here. So the partial solution will be found in the following form. So A cosine of x plus B sine of x. Yeah, we always need to find coefficients both for sine and for cosine. So now differentiating this solution. Partial solution to substitute. So minus A sine of x plus B cosine of x. Then y prime twice equals minus A cosine of x minus B sine of x. And now substituting it into the initial equation. So minus A cosine of x minus B sine of x. So minus 7 multiplied by this expression. And plus 6 multiplied by this expression. And it equals sine of x. Now let us expand brackets and find undefined coefficients. So plus 7a sine of x minus 7b, and here plus 6a and plus 6b. So now we will group coefficients around trigonometric functions. So yeah, but first of all, we'll simplify them a little bit. So we have here 5a cosine of x and plus 5b sine of x. So now we will regroup around trigonometric functions. So regrouping around cosine, 5a minus 7b cosine of x plus 7a plus 5b sine of x equals sine of x. So now we received the following system of linear equations. So 5a minus 7b equals 0, and 7a plus 5b equals 1. Okay, so I will not calculate these fractions. So yeah, so verified, yeah, that we received the same answer. So the solution of the system will be the following. A equals 7 over 74, and B equals 5 over 74. And then we have the following so the solution will be partial solution is the following. So let us write down like this: 1 over 74 7 cosine of x plus 5 sine of x. So the final answer will be the following. So C1 e in power of x plus C2 e in power of 6x plus this trigonometric expression. So it's done. Any questions about this exercise? Okay, I guess that no questions. So let's move to next exercises. Let's see what we have. What do we have here? Yeah, here we have Cauchy problem. Let us also look at other equations. Mhm. Okay. Yeah, interesting exercises. So now let's first of all move to let's solve Cauchy problems. Let's have some practice with them. So 2a. So the following equation: y uh, prime twice minus 2y minus 2y prime equals e in power of x x square plus x minus 3. So writing down the characteristic equation, so k square, let me also write down the initial conditions. So y from 0 equals 2, and y prime from 0 equals 1. So k square minus 2k equals 0. So k by k minus 2 equals 0. So it means that so k1 k1 equals 0 and k2 equals 2. So the generic solution will be the following. So not general solutions, solution of the homogeneous equation. So C1 plus C stop 2 plus C2 e in power over 2x. So yeah, C1 because C in power of 0. So this is the solution of the homogeneous equation. So now finding the partial solution. So the control number of the left part of the right part equals 1. It is not the root of the characteristic equation. So the partial, so y partial will be equal e in power of x multiplied by ax square plus bx plus c. So because here is polynomial of power of 2. So differentiating this partial solution, so y prime will be equal e in power of x. Yeah, first of all, so differentiating e, then plus 2ax plus b. Then y y prime twice equals so differentiating first of all e and then differentiating this polynomial. So 2ax plus b plus 2a. So now it will be simplified a little bit. So ax square plus 4a then plus 4ax, sorry, plus bx, plus plus 2a plus 2b plus c. So substituting it into the initial differential equation. So this expression minus 2 multiplied by this expression and equals this right part. So now canceling e, first of all. And expanding brackets. So minus 2a square minus 2b minus 2c minus 4ax and minus 2b. And now continue simplifying it. So something can be cancelled. Canceling a 4ax. Then canceling 2b. And actually that's all that can be cancelled. Yeah, here writing down, so minus a x square, then minus bx, so plus 2a and minus c. So received the following system of linear equations. But actually, yeah, so we can see that so minus a equals 1, so minus b equals 1, and 2a minus c equals minus 3. Let me check if the system is correct. Yeah, it's correct. So we find, so a equals minus 1, b equals minus 1 as well, and c equals 1. So the general solution, the partial solution is the following. So e in power of x multiplied by minus x square minus x plus 1. And the general solution will be the following. So it will be equal c1 plus c2e in power of 2x and plus this expression. And now we have to differentiate this general solution to find constants. So what do we have? So c1 will be differentiated to 0. So we have 2c2 e in power of 2x plus e in power of x minus 2x, minus x square minus x plus 1, so differentiated e, and then differentiating polynomial. So minus 2x minus 1. Okay, now let's substitute these initial conditions to find constants C1 and C2. So y from 0 equals 2. So 2 equals, so substituting, so C1 plus C2 plus, so here will be 1, here 0, 0, so plus 1. So received the first equation for constants, and y prime from 0 equals 1. So substituting 1, and here what I will have, so 2c, here will be 1, so 0, 0, 0, and actually it will be 0, so the whole this expression will be equal to 0. Okay. Again, let's check. So yeah, actually both constants are equal to 1 over 2. C1 equals 1 over 2, and C2 equals 1 over 2 as well. So the final solution, so solution of Cauchy problem will be the following. So 1 over 2 plus 1 over 2 e in power of 2x equal plus e in power of x multiplied by minus x squared minus x plus 1. I'll stop y9 here. It's a mistake. So it must be 1. Okay. Any questions about this exercise? Okay, I guess that no questions. So moving to exercise B. To B, we have the following differential equation. So y prime twice plus y equals minus sine of 2x. Then y from p equals 1, and yeah, by the way, it also equals y prime from p. So writing down the characteristic equation, so k square plus 1 equals 0. So it means that we have a complex solution, so even imaginary, so plus minus I. So the general solution will, not general solution, the solution of the homogeneous equation will be equal C1 cosine of x plus C2 sine of x. And what about the partial solution? So control number of the partial solution equals plus minus 2i. Plus minus 2i, so it is not the square, so it is not the root of the characteristic equation. So we will find the partial solution in the following form. So a cosine of 2x plus b sine of 2x. Differentiating it twice. So the y prime with wave equals minus 2a sine of 2x plus 2b cosine of 2x. Then y prime twice equals minus 4a cosine of 2x plus minus 2b minus 4b sine of 2x. And now substituting into the initial equation, so this expression and this expression. And it will be equal minus sine of 2x. So again, regrouping this, okay, first of all, simplifying this expression. So what do we see here? That so minus 3a cosine of 2x and minus 3b sine of 2x. And here we see that a equals 0 and b equals 1 over 3. Yeah. So the partial solution is the following. So it will be equal 1 over 3 1 over 3 sine over 2x. So the general solution is the following. So y equals this expression plus 1 over 3 sine of 2x. Let us also differentiate it because we will have to find constants. So minus c1 sine of x plus c2 cosine of x and plus 2 over 3 cosine of 2x. So finding finding solutions. So the general the exact solution. So y prime so y from p and y prime for p both equals 1. So substituting everywhere p. So 1 equals, so again, p writing everything in details. And yeah, let us simplify a little bit. So it will be equal 0 and cosine of p equals minus 1. So it will be eliminated. And here minus c2. And here cosine of 2p equals 1. So what I have that c1 equals minus 1 and c2 equals 2 over so 2 over 3 minus 1, so c2 equals minus 1 over 3. Let me check. Yeah, correct. So then the final answer will be, so y equals minus cosine of x minus 1 over 3 sine of x plus 1 over 3 sine of 2x. So this is the final answer. Any questions about this exercise? Okay. So exercise C will be your home task. Actually, yeah, so here order of 3, so much more interesting case, but yeah, you have this example solved here, but try to solve in your own, of course. And now let's have a break for 5 minutes, and after that we will continue solving linear differential equations with constant coefficients. Okay, let's continue. So moving to exercise 3, so 3a, and we have the following equations. So the task is the following: to determine the form of a partial solution of given linear inhomogeneous differential equation using the principle of superposition of solutions. And now we don't have to find exact coefficients, we just need to find the general part of this solution. The partial solutions will, so first of all, writing down the differential equation. So y prime twice minus y prime minus 2y equals e in power of x plus e in power of minus 2x. The characteristic equation is the following: k square minus k minus 2 equals 0. And the solution is the following. So it has two solutions. So the first root equals minus 1, and the second root equals 2. So found the found roots, but we even don't have to write down the general homogeneous equations. So the general stop minus 2x here. So we don't have to write down the solution of the homogeneous equation. So we need to write how the partial solution will look like. Here we can see that the right part is the following, so it is the sum of exponents. So it consists of two parts. So e in power of x plus e in power of minus 2x. So actually we can write down like this. So f1 from x equals e in power of x, and f2 from x equals e in power of minus 2x. And each of them has control numbers. Control number of f1 equals 1, and control number of f2 equals minus 2. Both of them are not roots of the characteristic equation. So we will just write down, y so y1 with the wave equals a e in power of x, and y2 with wave, so y2 partial will be equal b in power of e in b by e in power of minus 2x. And according to the superposition principle, so the partial solution will be equal to the sum of both these solutions. So it will be equal a e in power of x plus b e in power of minus 2x. Any questions about this exercise? Okay, if no questions, let's have more practice. So and then we have the next equation: y prime twice plus 4y prime equals x plus e in power of minus 4x. Writing down the characteristic equation: k2 or k square plus 4k equals 0. So k by k plus 4 equals 0, and it means that k so it equals it means that k1 equals 0 and k2 equals -4. So both of them, yeah, so we have these roots, and we can see that, so writing down actually the right parts. So f1 from x equals x, and f2 from x equals e in power of -4x. So what can we see? So the control number of f1 equals 0, because e in power of 0, and the control number of f2 equals -4. So both of them are roots of uh, both of them are roots of characteristic equation. So y1 will be equal, so ax plus b and multiplied by x, because so x in power of multiplicity -1. Oh, no, so x in power of multiplicity. So multiplicity is 1, so here multiplied by x. And y2 partial will be equal uh, b. Okay, it will be, okay, let's write down c. So it will be equal cx, cx e in power of -4x. And the general form of the partial solution is the following. So x multiplied by ax plus b and cx e in power of -4x. Any questions about this exercise? Okay, I guess that no questions. So moving to 3c. We have the following equation: y prime twice minus y equals x plus sine equals x plus sine of x. So writing down characteristic equation, k square minus 1 equals 0. So k equals plus minus 1. So we have two different roots. Real, both of them are real. And now looking at the right part. So f1 from x equals x, and f2 from x equals the sine of x. So the control number of f1 equals 0, and control number of f2 equals plus minus I. Both of them are not roots of the characteristic equation. So y, so the first, so y with wave 1 will be equal ax plus b, and y2 with wave will be equal it will be equal c cosine of x plus d sine of x. So the partial solution, so the general form of the partial solution will be the following: ax plus b plus c cosine of x plus d sine of x. So found it. Any questions about this exercise? Okay, no questions. So moving to the next exercise, exercise 4. Here we again will use the superposition principle, but here we will have to find the solution of the differential equation. So the general solution, of course, plus 2e in power of minus x, and writing down the characteristic equation. So k square plus 1 equals 0, then K1, 2 equal plus minus I. So the solution of the homogeneous equation will be C1 cosine of x plus C2 sine of x. So done with it. And now, so looking at the right part, so f1 from x will be equal x e in power of x, and f2 from x equals 2e in power of minus x. Control number of f1 equals 1, and control number of f2 equals minus 1. Both of them are not roots of the characteristic equation. So then y1 partial will be equal ax plus b e in power of x, and y2 equals c e in power of minus x. And now, yeah, the partial solution will have the general form the following: ax plus b e in power of x plus c e in power of minus x. So now let us differentiate this partial solution, and now we will do as we did before. So y prime with wave equals so ax plus b plus a e in power of x, and minus c e in power of minus x. And then y prime twice will be equal, okay, first of all, write in this expression, and then plus a, plus a multiplied by e in power of x, and plus ce in power of minus x. Now let us simplify it a little bit. So ax plus 2a plus b. And now let us substitute it into the initial equation. So so the second derivative plus this solution, and it will be equal x e in power of x plus 2e in power of minus x. Let us expand brackets and let us regroup all these expressions. So what we will receive? So 4e in power of x, 2ax plus 2a plus 2b. And what about e in power of minus x plus 2c e in power of minus x, and equals this right part. So now all of these coefficients are regrouped. So we can write down the following the following system of linear equations, but actually we even don't have to solve it with the respect. So c can be just found from the equation 2c equals 2, so c equals 1, and we just need to find a and b. So this part and this part, and so in this they are independent. So 2a equals 1, and then 2a 2a plus 2b equals 0. So what do we receive? So that a equals 1 over 2 and b equals minus 1 over 2. So the partial solution will be the following. So let us even write down 1 over 2 here. So x minus 1, and here will be 1. So this is the partial solution, and the general solution of the equation is the following. So C1 cosine of x plus C2 sine of x plus this exponential expression. So it's done. Let us check here if everything is correct. Yeah, correct. So here is the final answer. Any questions about this exercise? Okay, I guess that no questions. So let us solve one more exercise. So 5a. Uh, uh, so we will have to solve the linear inhomogeneous differential equation using the method of variation of arbitrary constants. Why we will use it? Because here we have so not a special kind of the left part or the right part. So that's why. So it is tangents x. So not sine, not cosine of x, not exponent, and not a polynomial. So actually, yeah. So we cannot use such approach that we did before. So here we will use the method of arbitrary constants. First of all, of course, we have to find the solution of the homogeneous equation. So writing down the characteristic equation, so k squared plus 1 equals 0, from which we can find that k 1, 2 equal plus minus I. So y homogeneous will be equal C1 cosine of x plus C2 sine of x. And then how to use the method of arbitrary constants. So actually, I will have to solve the following system. So I will have to find, yeah, by the way, so y will be found, so partial solution. Y will be found by the following formula. So yeah, remember in first order differential equations, so we consider that C1 and C2 are functions that depend on x. And they will be found by the following formula. So C1 prime y 1 plus C plus C2 C2 prime y2 equals 0, and then so C. So I'm writing down the generic formula for now. So C prime 1 y prime 1 plus C prime 2 y prime 2 will be equal f from x. So this tangents of x. And now we will just substitute everything into this system. So C1 cosine of x plus C2 prime sine of x equals 0. Then here will be minus sine of x, and here will be cosine of x. And instead of f from x, I set up tangents of x. So I need to solve this system with respect to C1 and C1 prime and C2 prime. Actually, how to solve it? So we can, so considering that it is the system of linear algebraic equation with respect of this variable, so we can use it with. So we can solve it with the Cramer formula, for example. So if we, so we can now consider these functions as constants. So cosine of x, sine of x, minus sine of x, and cosine of x. So the determinant will be cosine square x plus sine square x, and so it will be equal 1. So then calculating delta 2. So here will be 0, and here will be tangents of x. So received minus sine square x by cosine of. Okay, let us write down first of all minus sine of x by tangents of x. Oh, it's delta 1. And what about delta 2? So it will be equal, so the following determinant. So here 0 here and tangents of x here. So it will be equal sine of x. Then, so C1 prime. So C1 prime will be equal minus sine of x by tangents of x. And C2 prime will be equal sine of x. Okay, now we will find these constants from so with integrating so we will integrate C1 and C2 and then find so we will find integrals. So sine of x tangents x dx. So it will be equal, so the following integral, so sine of sine square of x over cosine of x dx, and yeah, it actually will be written in, so we can write it in the following way. So 1, okay, it will be written as 1 minus cosine square of x. And after that, I will expand. So here I have 1 over cosine of x, so seconds. And here I will just have cosine of x. So the integral of seconds, let me check. So yeah, I not always remember this formula. So integral of 1 over cosine of x will be equal logarithm of tangents of x over 2 plus p over 4. And minus sine of x. So actually, yeah, and c will c1 will be equal, yeah, don't forget about minus here, so it will be equal sine of x minus this logarithm. And of course, c2 will be equal minus cosine of x. So found these constants, and then how, so again, for differential equations of, so for all non-homogeneous differential equations with the constant coefficients, solutions are found by the following algorithm. So in the following form, sum of solution of the correspondent homogeneous equation plus partial solution. So actually we found the partial solution. Yeah, and first of all, let's write it down. So y partial will be equal the following function. So for c1, so this expression will be multiplied by cosine of x and minus so cosine of x by sine of x. So now I will simplify it a little bit. Simplifying, so let us expand brackets. So sine of x and here minus sine of x by this logarithm. So the final answer will be minus sine of x multiplied by a logarithm. I mean the partial solution. And the final solution, so again, so y0 plus y with wave plus y partial, and it equals so c1 cosine of x plus c2 sine of x and minus sine of x multiplied by a logarithm of module tangents of x plus 2 plus or x over 2 plus p over 4. So this is the final solution, the general solution. So yeah, it is actually stop y minus. Yeah, so correct. Yeah, because yeah, here cancelled. Okay. Maybe any questions about this exercise? Okay, you have no questions. So let us solve one more exercise. So we will have more practice in solving differential equations with constant coefficients. So we will solve the following equation. So e in power, so y prime twice minus 2y prime plus y will be equal e in power of x over x. So the characteristic equation is the following. So k square minus 2k plus 1 equals 0, and it means that k 1, 2 equals 1. So multiplicity of the root is 2. Then writing down the solution of the homogeneous equation, it will be the following. C1 e in power of x plus c2x e in power of x. So now we will again find the partial solution in the following form. So C1 from x e in power of, okay, let me just write like this. Oh, no, Control C. So C1 and C2 will be functions that depend on x. So again, writing down the system for C1 and C2. So C1 prime e in power of x plus C plus C2 prime x e in power of x equals 0, and then derivatives of y1 and y2. So C1 prime e in power of x plus C 2 prime x x e in power of x plus e in power of x equals this expression, e in power of x over x. So solving this system, again, let us use grammar formulas. So e in power of x here. Here will be x e in power of x, and here x e in power of x plus e in power of x. Okay. So what I have? So x e in power of 2x plus e in power of 2x and minus x e in power of 2x. So it will be equal e in power of 2x. So calculated delta, then delta 1. So here will be 0, and here e in power of x over x. And actually it will be equal e, so e in power minus e in power of 2x. So it will be 0, and x will be cancelled, so minus e in power of 2x. Then delta 2. So 0 here, and e in power of x over x here. And I will receive e in power of 2x over x. So now we will find the constants C1 and C2. So first of all, derivatives of C1 and C2. So C1 prime will be equal, so delta 1 over delta. So it will be equal minus 1. And C2 prime will be equal delta 1 over delta, or delta 2 over delta. So it will be equal 1 over x. Then C1 will be equal minus integral of dx. So it will be equal minus x. And C2 will be equal integral of 1 over x. 1 over x dx. So it will be equal logarithm of module x. And now writing down the partial solution. So the partial solution is the following. So y with wave will be equal. Okay, I will just substitute here instead of values instead of C1 and C2. So C1, so minus x, and C2 logarithm over x. Mhm. And I also can even simplify it. So I will factorize. Yeah. So x e in power of x logarithm of module x minus 1. And the final solution will be, so general solution y0 plus y with wave so it will be equal C1 in power of x plus C2 x in power of x and plus this expression x in power of x multiplied by logarithm of x minus 1 logarithm of module x minus 1. Let us check here. Yeah, actually the same answer. Any questions about this exercise? Maybe about the whole lesson, about previous lessons? Okay, so if no questions, let us finish. So have a nice day, stay safe, and don't forget to register on competition. And yeah, so if you have questions, feel free to text me. So have a nice day. Goodbye. Thank you for your attention.
Thank you for your lesson. Bye.
Bye.
Thank you for this lesson. Take care.
Thanks.